All right. So good evening, everyone. We are back for our training on Agentic AI. Before we jump into today's class, I just want to ask, right from our very first day, do you have anything, any confusion, any unclear, any gray areas that you like to be clarified? Because the further we go without things being clear, the more anybody who is getting lost keeps getting lost. So is there anything that you'd like us to clarify? Is there any discovery that you've made that you would like to share with others? Maybe that will be helpful to them too. Yes, Olanre, would you please go ahead?
Good evening, sir. Good evening, everyone. Thank you, sir. Please, sir, it's about the last class that we had. I had some, I couldn't follow live during the class, so because of the issue of my ID and the likes. But then, after all, I followed the instructions. But then the error I was getting was that's when I get to the place of invoking the LLM to provide the summary output. To say, please provide me with the text you would like me to summarize. I need the text to be able to summarize it for you. I kept saying that forever. The code will run to that point, to tell me, please provide me with the text you want me to summarize. Even though the text variable has been run before it's supplied. I don't know why, that's why I got stuck.
Okay. What model were you running?
Olama, sir.
Olama is not the model.
Class.
Olama is not the model. It's
the Gemma, the one we use in class.
Which of the Gemmas?
Gemma 3, 1 billion. That's the one I had on my system.
Okay, that's actually that I noticed that he was doing that quite a bit. So, but and I think Gemma 2, the 2 billion parameter, Gemma 2.2, I think. Gemma 2.2 was also given that, but was rare. Gemma 3.4, the 1 billion was given that like consistently. But when I tried Llama 3.2, the 3 billion parameter model, it ran without incident. And when I tried bigger models too, it ran without incident. So I think it's an issue with the model capacity.
Okay, so my main challenge was that's why I don't know. I don't know why. I mean, I don't know the constraints around our YouTube video not being uploaded earlier on. Because I waited out. It seems it was just 2 days ago. Because since I couldn't follow the live class, I didn't know exactly. I know there's some challenge too in the class. We asked people to try this. I didn't know what exactly. Maybe that's the same error they were having, not.
Yes, it was.
Okay, is it the same errors, but they couldn't find summary?
Yeah, particularly when you run the full chain. When you run the full chain. But I think if you run only the summary chain, it was able to do the summary. But when you run the full chain, it complains that it doesn't have the summary to do the sentiment analysis. Go ahead, please.
Finally, sir, based on the advice you gave earlier today on CodeSpaces, I've already gone to GitHub and created a repo, then got into CodeSpace. Now I found that one can just add all this. So I think I'll just abandon VS Code. Though I understand that one can use VS Code interface there. So that one does not have. I believe the issue of Gemma 1B, 3B that we have now will not surface if one is on CodeSpaces. Am I correct, sir?
Well, it will still be, you're still running small models. The CodeSpaces.
No, one can pick a bigger model without stress.
It's still, well, it depends on your, you should be able to run more than the 1 billion parameter model. code spaces. Also depending on this particular specs you choose, but know that when you choose a larger machine, then you have fewer hours that you can run in a month on the free tier.
Okay.
So you need to achieve a balance.
All right, sir.
One other thing I think we are going to do probably before the next class, that'll be tomorrow, at least before next week, is let us all try to have our Grok API keys so that let's see if we can start using the Grok models, because it seems most of us, our system specs are not able to run any reasonable model on Olama. So I probably will use the Grok models, which will allow us to use slightly bigger models.
Thank you, sir.
Does anyone have anything that needs to be clarified? If not, then let's get to business. Yeah, I take it that that is a no. So we move ahead. So today we're going to talk about function calling and structured LLM responses. But before we get into the business for the day, like we usually do, we start with a recap of the previous week or the previous day, as the case may be. So who can give us a recap of what we talked about concerning agentic development frameworks and LangChain expression language and LLM chains? Who can give us a recap? Anyone? No one. Okay. Kenneth, please go ahead.
Okay. So can you guys hear me? Am I audible enough?
Yes, you are.
Okay, so last week we touched on agents, my frameworks, and this simply allows my developers to create agentic system with ease, because this framework like consists of pre-built in toolkit that's like fast in the process operating the system. So I think then we proceed to also speak about the examples of the agent frameworks. We touched on LangChain. LangChain is a framework for LLM orchestration. We also touched on Llama Index. Llama Index is also a framework that ingests data and index for retrieval. I think we also touched on Crew AI. Crew AI is also a framework that allows us to build multi-agents. That's got to use LangChain to interact with our local models through Olama. So that was what we did last week, basically for me, and that was what I can remember. So if anyone also has something to say, like they can also say, or maybe if you okay, or so maybe if like you could correct me if I was wrong somewhere. Thank you.
Okay, well, you are basically correct. It's just an overview. One very important thing that we tried to touch on last week was the lang chain, expression language, and LLM chains. And I would encourage everyone to just play around with building different chains. Yes, we worked on a sequential chain, but I think you should also explore parallel chains. We may not, and I don't know if we'll be able to take time in this course to do that, but we probably would need parallel chains somewhere down the line, so it would help if you already friendly with them. So it's something I think you should try on your own to play around with. And the truth too is that we will never have enough time, enough hands-on time during the class. We just have 1.5 max 2 hours twice in a week. So you need to do most of the practical on your own, and then probably ask questions, make contributions in the Slack, or not Slack, we use a Discord, so that all of us can contribute and we share ideas, and that's how to improve um, on your agentic AI skills. So let's get into our business for today. LLMs have one key problem that limits how useful they can be in real world use cases, and that is that they are text-based. From their name, large language models, they are based on language and text. Yes, now today we have multimodal models that can take video, other forms of input, but at their core, large language models are text-based. So that's a very serious limitation on what they can do, what they can be used for. Now, APIs need structured data, and already, I mean, there's a whole lot of APIs, a lot of services run on APIs, and so for LLMs to be useful, they need to interact with these APIs, but they are just text-based, so the two are incompatible. And there's also the fact that in real life use cases, it may not just be about maybe doing some math, getting the answer to a math problem, or processing some data, or there may also be the requirement to carry out some physical action, well automated, controlled, maybe by some form of electronic intelligence. But LLMs are limited in their ability to interface with such systems. And that's where function calling comes in. It provides a bridge between... Joyce, please mute yourself. So function calling provides a bridge between the text-based LLMs and these APIs, and well, even the actions, the interaction is via APIs. So between the text-based LLMs and these APIs that need structured data, let's say JSON data. So function calling allows the LLMs to interface with these APIs, so they interact with their environment and they take actions that are beyond their inbuilt abilities. So since they are essentially just next token generators, if you remember what we talked about when we looked at what LLMs in our first or second class or so. So yes, LLMs can actually generate structured output without function calling, right? But that is still somehow limited. And the way you can get them to generate such structured outputs is by guiding them through guiding their response formats in your prompts. If you remember, when we were looking at prompting and prompt templates and so on, we talked about one of the characteristics we mentioned for a good prompt is that it specifies the output format, right? Now, how specific, how detailed that specification is really depends on the use case. It could be an overkill or not. It depends on the use case. And so the techniques that can be used in guiding the LLM response formats include prompt engineering, like we try to do in some of the demonstration we had in class, the assignment that you did where you specify, I want the output this way, and even though we didn't do so much of really structured outputs, right? And then some models also have a JSON mode. Well, that is provider specific, but I know that providers like OpenAI, Google Gemini, Anthropic, and so on, they have models with a JSON mode. And so if you switch on that mode, your model can output JSON data. There's also schema enforcement. Yeah, I'm using like JSON or schemas or pedantic object schemas. One way to look at it is we talked about output passers when we were talking about chains. So an output passer really serves to enforce, its job is schema enforcement, to enforce the output schema of the chain in which you integrate it. The use cases for these structured outputs include data extraction, content moderation, and classification. But the important thing is structured output helps to make the output of your LLM, make it more easily integrable into pipelines, right? But then there's also a limit to what you can get, because essentially LLMs are to a large extent stochastic. There's a bit of should I use them randomness in their output? Yes. The temperature parameter allows you to control how variable you want the output to be, but in the end, like we had talked about earlier, the output really depends. The specific wording of your prompt influences the output a lot. So by just changing one word, you can actually get quite a different output, even though the meaning of your prompt remains the same. Now, what is function calling? Function calling is the same thing as tool use. So if I say tool use, I mean function calling. If I say function calling, I mean tool use. It's function calling is simply a way or a type of structured output, LLM outputs. It's where the LLM outputs JSON adjacent object that represents a function call, including the arguments of that function. Now, it's important to note here that the LLM itself does not execute the function. All it outputs is that JSON object representing the function call and specifying the arguments to the function. It is your application, the application that is built around that LLM. It is that application that actually executes the function. The job of an LLM in function calling is simply to reason about the intent, is to evaluate the prompt, the instruction it was given, and to determine whether a function call is necessary. And if a function call is necessary, which function should be called based on the functions that are available to it in its environment. And so when it makes that, when it determines that function A should be called, and it should be called with these parameters and these values for these parameters, it outputs that JSON object. And then the specific mechanism in the environment will pull that JSON object and execute the function with the specified parameters in the LLM's tool call output. There are LLM models that natively support function calling. Providers like OpenAI, Google, and Anthropic, and so on. They provide a number of function calling enabled, tool use enabled models. Does anybody have any question at this point? Yes, Olari, would you please go ahead? Olari, are you there? If you're trying to speak, you're muted. But I see that your hand is raised. Okay.
Yes, sir. Thank you, sir. I just want to ask about the function calling function, so to say, or ability. Like you said in the third bullet point, you said LA does not execute the function. So, for instance, I think you made mention of like in the earlier part of the class, like when we talk about agents, that they will reach out to maybe a tool that they want to use. I think this is a kind of it. So maybe let's say it doesn't need to call a calculator or call for weather API or something. So it means that when the function is called, maybe the weather whatever, maybe the weather server is called or reached through an API, then the outputs will be given. So my question now, sir, is that you specified, I mean, you mentioned here JSON. Does it mean that there is no other output format? And secondly, is it the tool that is maybe the weather server now or the calculator that will determine the output format, or is it LLM that will specify, since we are not using prompts this time around? I don't know if my question is clear, sir.
Sorry, I was muted. I had actually started responding. I forgot that I was muted. The function calling essentially makes use of JSON, the JSON format. And like I mentioned earlier, the LLM does not execute the function itself. Its job is like the reasoning engine of the agent in an agentic workflow. So it just reasons, it evaluates, it triages to determine whether it's necessary to call a function, and if it's necessary to call a function, which function. Of course, it only knows about the functions that are available to it in this environment. And so if there's no need to call a function, we're going to get to that shortly. But the important thing is it's just like, let's say you have a car, or let's say you have a plane of your own, and you want to travel to somewhere that's very far. It's not feasible to walk, and it may not be feasible to drive in a car. So you have a pilot who flies your plane. Now, for you, your own is, I have a meeting. Let's say you are in Ghana, or you are in Kenya, and you have a meeting in Geneva. So you're supposed to be at a meeting in Geneva at so time. So if you determine that the best way for you to get there in time for that meeting is to take a flight, right? So all you need to do is to inform your pilot, hey, I need to get to Geneva. That means you determine that there's need to make use of that flight function, and you've provided the parameters, which is where you want to go and when you need to go. It's now the pilot that will fly that plane with you in it to Geneva. So you, in this case, are like the LLM. Your job is to, based on the intent, based on the objective, determine whether there is any need to call a function, and if there is need to call a function, which function. And once you provide that JSON output, it's now left for the environment in which the LLM is running to implement the mechanism to actually execute that function. So based on that JSON output, whatever mechanism the environment has will pull out, this is the function that should be called, and these are the parameters with which that function, these are the arguments with which that function should be called, and then it executes that function. The LLM's responsibility in this case is just to determine whether a function should be called, which functions should be called, and which arguments it should be called with. Does that clarify? Does that adequately answer your question?
Yes, it does, sir. Thank you, sir.
Okay. Does anyone else have any question? Okay, so fine. All right, so function calling flow. Now, for you that are using the LLM to achieve some intent, what you do is to provide, let's assume that the LLM called app or agent or whatever it may be is already built, right? What you do is to provide it with a prompt, and then it does its magic and gives you a response. Now, but how does this actually work? First of all, in building that function calling LLM based app or workflow, as the case may be, you need to define the functions or tools that the LLM can call. And to define a function or a tool, you need to specify its name. And very importantly, you need to provide a description, because it's based on that description that the LLM can determine when that function should be called. Is based on that description. So you need to provide a description, a clear description of that function. And you also need to provide a JSON schema of the function parameters, because it's based on that JSON schema that the function can construct, that the LLM can construct the function calling output and provide that JSON function calling response, which will now be used by the environment to execute the function. So after defining the function tool, if the function tool has been defined, then you can use, and well, if it has been defined and made accessible to the LLM, then you can just call the LLM, send it a user prompt, of course, with the tool having been made available to it, you send it a user prompt. The LLM evaluates your instruction, your request, and figures out whether or not a function call should be made. If it decides that there should be no function call, it responds the typical way it does, with some text response. Maybe it just gives you an explanation or something. But if it determines that a function should be called, then it needs to figure out which function out of the ones that are available to it. And when it determines that, and also figures out which arguments should be provided to that function call, it generates the JSON function call response, and that's what it outputs. And that's it. It's now left for the execution mechanism in the environment to actually implement the function execution. Now, what's the anatomy of a function or a tool declaration? Is simply what we talked about. The name of that function or tool, its description, and the schema of its parameters. These are the three core things you need to provide when declaring a function or a tool. Any question? We move ahead. Okay, I take that to be a yes. Now, here is an example of a function definition. Here you see it's a variable, a JSON array that has well, in this case, it's just one JSON object as a member. But if you have multiple functions, multiple tools, each one will be a JSON object in that array. This particular definition is queued towards the OpenAI function calling. The tool object within the array, it has a type key which specifies that it's a function. That's what shows that it's a function call. And then there's a function key, which is an object that now provides or contains the other details about that function, the actual details about that function anyway, like the name. In this case, this is get current weather. The description, get the current weather in a given city using Celsius or Fahrenheit. And the parameters, the parameters the value of parameters is a JSON object, is a JSON schema of this function, the get current weathers function. And the first one is an object. Well, the parameters itself is an object. The first parameter is called properties, or not properties, it's called location. These are the properties of that parameter object, which parameter object. The properties are the actual parameters of that function call. And the first one is location. It's a string, and it's described as the city and state where you want the weather the function to give you its weather, and it gives an example. The second parameter is unit, and that's simply a specification of whether you want the temperature in Celsius or Fahrenheit. And if you look at the description for the unit parameter, you will see that it specifies that that parameter defaults to Fahrenheit, meaning that it's actually an optional parameter, right? And if you go further down, you see where it specifies the required parameters. It's a list, and here it contains location, which confirms the fact that unit is optional. And you also see the enum here that specifies that units can only take two values, the members of that enum, which is Celsius and Fahrenheit. So essentially, this is enough for the function execution mechanism in the environment of the LLM to know which function the LLM wants to be called and what well, this is a schema. So in the actual function call, it will provide values for that schema. I'll show you an example of the actual function call response matching this. And the question I want to ask, but before I ask my question, does anybody have a question on this before I ask my own question? Okay, Olara, would you go ahead, please?
Yes, sir. Thank you, sir. Can you hear me, sir?
Yes, loud and clear.
Yes, I don't know if I'm audible.
Yes, you are audible.
Can you hear me, sir?
Yes, I can hear you loud and clear.
Thank you, sir. Okay, sir. In this code you gave us, I'm looking at it. The last part that you call units, based on the condition that was specified that it is optional. I guess it may also mean that one may actually remove that unit entirely so that the code will end property will only be location, that unit. And
No,
it will work.
no. This is a function definition, right?
Okay.
You're not invoking the function. This is just for you to define the function. It is based on this function definition that the LLM will know that, well, when you provide this function definition to the LLM, it will be based on this function definition, know that there's a tool, there's a function called get current weather that's available to it to use. And that this function called get current weather provides, it retrieves the current weather in a specific city, and that it can give you that weather. The weather it actually gives, in this case, is temperature, since it's saying using Celsius or Fahrenheit. So essentially, it gives the temperature in a specified city, either as a value in Celsius or a value in Fahrenheit. And that to call this function, it needs to provide two values, one representing the location, that's the city whose weather it wants to get, and the second one representing the unit that you want the function to use in when providing it with the temperature value. But it also knows from this that it must not provide a value for unit, that it can omit the value for unit when it's requesting that that function be called on its behalf, and that if it omits that value of units, it's the same as explicitly providing the value of Fahrenheit. So this is just a tool definition. It's not actually the LLM response where it requests for this tool to be executed.
Oh yes, I
Does
get
that
it now, sir. So that means if it's not specified, then it means it's Fahrenheit.
when in the
The unit is
LLM,
not
when the LLM
specified.
is trying to call, if it's not specified, it means Fahrenheit. But if you remove that, something you're going to speak after we clarify Olanrewaju. If you remove the reference to units in this function definition, it means that the LLM will never ever provide a value for units. That means automatically whatever temperature it gets will always be in Fahrenheit. It will never ever get a Celsius value.
Okay, sir. Thank you, sir.
Okay, Samson, please go ahead.
Thank you very much. Good evening, everyone. So, yeah, the only okay. First question is this type of
Samson,
that's
I
the
can't
first
hear you
question.
anymore.
This type object.
Yeah, what about
Can you hear
it?
me now?
Yes, I can hear you.
Yes, I said what's the purpose of this type object?
Okay. How familiar are you with Python?
Very good.
Very well. It's the same thing as type. The type of a variable or the type of
Can you
any.
hear me?
Yeah, I can hear you.
You said what?
Is that
Yeah,
same
I
type?
said
Is that same type in Python that is there? So when
okay.
you have a variable and you do type variable, that's the same thing. It's just specifying that this is a function. So it's specified that this definition is for a function.
Okay. The second one is so now because I could only see that in the description, that's where we you kind of like type defaults to Fahrenheit, but I didn't see where the default was being set. So that's the other question I want to ask.
If you look at well, the default value is not set here. This is a function definition for the LLM. It is okay. Let me use another name. This is like a manifest to the LLM for it to know that there's a function and that this is how it can request that that function be executed. I guess the use of the term function definition can be confusing. You will still have that function defined in your code. Or what this is just is like a manual to the LLM to say, hey, there's a function called this. These are the parameters it takes, and this is how you can call the function. That is what this is.
Okay.
All right. So
Thank you.
Mustafa, you may go ahead, please.
All right, thank you, sir. My question, one of my questions has been answered, so I'm not going to be asking that again. So I move to this question. The comments, like the way you commented in the function then to call, is it that this is to guide the person reading the code, or it's going to be as a guide for the LLM? So
Which of the comments in this case, all the code comments?
The comment here where you have optional constraint. the model's output.
Code comments are essentially for the, in this case, the human reading the code.
Okay.
I put this here because we are trying to learn about tools calling, right? That's
Yes,
why
sir.
that's why that is there. Essentially, what that is saying is that enum specification, that specification unit is essentially this specify that is a string enum, is an enum string. You can remove it, right? If you
Yes,
remove
sir.
it, the function definition is still valid. However, removing it means that you increase the likelihood that maybe the function will expect something in Kelvin. But you should know that the function is not the LLM is not executing the function. The function is already built. So it is what it is. This is just for the LLM to understand, because typically when the tool is actually executed, the results of the output of the tool or function still becomes available to the LLM, and it may be the basis for its next action. It may use that response, that output from the tool, as input for its next action, or it may just, well, the next action can as well be providing some information to the user. So it's good for the function to actually understand that, hey, if I specify this is what it is. And so if it does not specify units, it knows exactly that whatever value it's given from the function execution is in Fahrenheit. Does that adequately answer your question?
Yes, sir. Thank
Okay.
you, sir.
Does anyone else have any other question, or do we move ahead? Okay, so I guess we move ahead.
Also, the
Yeah, go ahead,
indentation too is a bit confusing. So I don't know.
What's
For
confusing
me,
about it?
Okay. Okay, I think I got it now. Yeah. I just have to, look at it deeply. So yeah, I got that now. Thank you, sir.
All right. Okay, so here's another tools definition. I didn't change. I still left this as example one. Yes, Adobe, please go ahead.
Yes, you said you wanted to ask question. So just
Yeah.
before that, you were
Yeah, thanks for
asking if
reminding
we
me.
have questions. So I'm still waiting for the question.
Okay. So my question now is this, based on this function manifest, based on this function definition, who can give us the, okay, let me rephrase it for to avoid ambiguity. Based on this function manifest, who can give us the actual definition of that function? If you are asked to write this, the signature of this function, if you're asked to define this function, who can do that for us just from this manifest? Olariwa, did you want to go? Your hand is raised, Olariwa.
Hello, can you hear me, sir? I'm sorry.
Yes, can I hear now?
Can you come again with the question so that I'll be sure I'm answering the right question, sir?
Okay, these are two manifest examples. I'm carefully using the term manifest in this case to avoid confusion. Looking at these two manifest example, can you give us the definition, the Python definition of that function? Well, you can, it doesn't really matter the language you use.
Yes, I get it now, sir. The very name is get_current_weather that will be defined prior to this.
Give us just read out what you would write if you were to write this, if you were asked to
Okay,
go and implement
okay,
that
sir.
function in Python. Give
Okay, so I
us
will
what
write,
you.
is I will write def
Yep.
get_weather_current_weather brackets. I will supply the parameters given here, location and description. Then I close bracket, colon. Then I will enter that to indent it. Then I may now say inputs.
That's fine. The specific implementation is not important here. Samson, before you speak, what I want to ask us to do is that each of us writes your own definition of this function, how you define it, assuming you are implementing it in whatever language. Do that in the chat. Samson, go ahead, please.
So, in the chat, do you
No,
mean Zoom or?
yeah, I will just put it in the chat. Yeah.
Here on Zoom. Lara, do you want to say something else? Your hand is still raised. Okay. Nobody has written their own definition yet. Maybe, but you need more than the function name. When you're defining the function, you need more than the function name. When I'm referring to your function, you just have the def keyword and the name of the function. You need more than that to define a function. Okay. Mustafa, that's fine. Anyone else? Good. I was actually waiting for type hints. Try as much as possible to include type hints in your code. It's helpful, right? Yes, he used a literal. You could also use an enum, which actually would be more what's the term? Semantically using an enum would be better since the function manifest specify that enum, but I mean using a literal still does the job and it's even simpler. So that's basically it. We move ahead, right? Here is another definition of the same function, but this one is skewed more towards the Google API. Now you see that we have the name of the function, we have the description of the function, we have the schema of the function parameters, where you have the first parameter with name, location, type string, and description, the city and state, example, San Francisco, California, just like in the previous example. And unit is of type string and has description, the temperature unit, either Celsius or Fahrenheit. In this case, it indicates that it defaults to Celsius. So this is slightly different. And yeah, and that's something that was missed by everybody who wrote the function definition. Sorry, I forgot to mention that. You did not indicate the default value. Okay, Samson did. Samson did, that's very good. Mustafa and Adobe, you did not indicate. Okay, Adobe did too. Good. So notice that this also specifies that location is required, implying that unit is optional. So the key takeaway here is that to define a function, you need to specify its name. You need to provide a description for the function, because that description is what enables the LLM to determine when that function is necessary, when it's necessary to execute that function. And you also need to provide the schema of the function's parameters, because it's based on that schema definition that the LLM knows what arguments to use when requesting that the function be executed. Now, here is an example function call output from an LLM. So when, assuming you ask, when the LLM determines that a function should be called, this is the kind of output that it will provide. And it's based from this output that the execution mechanism in the environment, in the application, will extract the name of the function and the arguments to be used in calling that function, and then it will implement the function call. And what the results, the output of the function call, will also be available to the LLM, which it would use as it's part of its input for the next step. And so let me ask any question, because I have my own question too. But let me know if you have any questions, so we can address your questions first before I ask mine. Okay. I take it that you don't have any question. So here, my own question is this. Looking at this true call output from the LLM, the example one on the screen, I would like you to type in the chat a prompt, a simple prompt that could have resulted in this output from the LLM, in these two call requests from the LLM.
Please, can you come again?
I'm saying, looking at this example to, oh, there should be a slash between tool and function. Looking at this example to call output from a function, from an LLM, rather. Type.
Now, what I'm seeing on the screen is the example LM2 function call output, sir.
Yes, is that what I said? Looking at this example LLM function call output.
All right, sir.
I would like you to type in the chat here on Zoom, type an example prompt, a simple prompt that would have resulted in this, in the LLM, requesting this function call. Okay, now, Kenneth, if you ask the LLM what the weather is in Ghana, and it makes this request for a function call, do you think that LLM is reliable?
So based on like checking the list that contains the object, I think maybe I should have added the temperature. I think like that one will give me the precise output. But I just leaving it at bare at what is the current weather in Ghana, like, I know give me the precise output.
Okay, my point is this: if you ask the model to tell you the weather or the temperature, as the case may be, in Ghana, and it's requesting, yeah, I can hear you.
Okay.
But my point is, if you ask the LLM to give you the temperature or the weather, whichever one, in Ghana, and it requests a call to the get current weather function with the value of New York City as location, wouldn't that be a hallucination? Unless there's a place called New York City in Ghana.
Okay, so since the location is a placeholder, I think like we are free to output, or we are free to enter any city that we want to search for.
You're still thinking about prompt templates. You're still thinking about prompt templates. This is not a prompt template. It's not a prompt template. That was a function called Skiba that we looked at earlier.
Okay.
So those are not placeholders. They are not placeholders. This is just JSON, or not this. This is JSON.
Okay.
So those are not placeholders.
Okay.
Now,
JSON output.
Yeah.
I get it now.
Samson mentioned in Celsius. Daniel mentioned in Celsius. And that's good. It's good to specify that, because I mean, you requested Celsius. That means for you to have said Celsius, typically the person would have asked, but then it could also be that the person didn't ask and it defaulted to Celsius. But given that the function also, the unit parameter is optional, I mean, if the person did not specify, I'm not sure, if the person did not specify one way or the other, I'm not sure it makes any sense for the model to go including that, because remember that for paid model use, you are charged per token. Yeah, it may be a small amount of money for a single token, but little drops of water add up to an ocean. Anyway, this is where for round off day, and on Thursday we'll continue with specifying tools and exposing them to LLMs. Does anybody have any question or any contribution? Yes, I'm doing it. Please go ahead.
Just a simple question. Sorry, give me a few seconds. Can you hear me?
Yes, I can hear you.
Okay. So I just want to ask if there's no, okay, if the unit here from this output is in Fahrenheit, that means that the prompt did not specify the unit, right?
Well, it depends on whether it depends on which manifest was provided to the function. In this manifest, Celsius is default. In this manifest, Fahrenheit is the default. So it really depends on the manifest that was provided to the LLM. Sorry. I think I've been saying function a lot today when I intended to say LLM. So we can't really determine which one it is, since we have two different
Okay. Yeah, I was referring to this particular one.
Which one? The one where Fahrenheit is default.
Fahrenheit, yes, default, yeah. I was referring to that one.
The truth
But
is
I
that
get
since
your point,
there's a default value, we really can't say, right? The model can provide that value argument, or it can omit it. It only becomes a problem if the person specified and the model is giving a different one from the one specified by the person. That's hallucination. Larry, do you want to say something?
Yes, sir. My question also overs around the I don't know if I'm audible.
Yes, you are.
Thank you, sir. Based on the given definition of the function, and a prompt is now given saying what is the current weather in Celsius, and the base or the default is Fahrenheit. Would it be assumed that the LLM has the capacity to convert Celsius to Fahrenheit, or it will need to call another tool to get that function done?
Well, if since the get current weather function already provides the capacity to convert, to give you the weather in the specific units, whether Celsius or Fahrenheit, it will be inefficient for the model, for example, to request for Fahrenheit temperature if what it really wants is Celsius. So requesting for Fahrenheit implies you get Fahrenheit and you now still go trying to convert from that Fahrenheit to Celsius. You either would have to do the calculation yourself, or you now referring to the model, or you have to make another function call to request for conversion. I mean, it's inefficient. So if a model is behaving that way, then that model is not efficient. And did that answer your question, Audrey?
Yes, I does. I'm just thinking, sir. Sorry, sir. I'm thinking. Since it's a tool calling, it means, like you told us before, sir, it means this is an LLM that is calling this function. And
No, the
then
LLM is not calling the function. The LLM is providing this JSON output based on which the execution mechanism, whatever it is in the app, would actually call the function.
okay.
So the LLM doesn't call the function. What it essentially does, this output is like a request saying, hey, I beg, help me call this function. But it's actually not calling the function. So there's some other mechanism to call the function that needs to be implemented in that app.
Okay, so I'm trying to look at the scenario you gave, sir. Because I remember you likened the LLM to a human being using the flight scenario that somebody needs to fly somewhere and he knows the right tool to use is the plane. So he just give instruction to the system, so to say, to the agent
Yeah.
that I want to go to
The
take me to,
LLM
I need
is
to be at so and so and so time.
not the agent in this case.
Okay.
Because if you say the agent, the LLM will typically be the brain of the agent. So it's given, it's just like I said, the typical person does not know how to fly a plane, but can know when it's necessary to take a flight.
Yes.
So the LLM now is the typical person. It knows it's necessary
that's
to
the
take
reasoning.
Yes, it knows it's necessary to take a flight to so and so place at so and so time. It knows, okay, it knows it's necessary to move to a so and so place at so and so time. It's able to decipher that the best way to make that movement is by taking a flight. But since it is not a pilot, it doesn't know how to fly a plane, it needs to rely on someone else to fly the plane. So it informs the person, please, I need to take a flight from so and so place to so and so place at so and so time. And that person will now, being a gracious person, will now oblige him by flying the plane with the LLM on it to that place at that time. Well, sometimes the person might refuse to fly the plane, or the person might maybe make a mistake while flying. But the important thing here is that the LLM does not fly the plane. It only requests to be flown on the plane to a given place at a given time.
Okay, the only LLM will just send a request.
Exactly.
That a plane should be called.
Exactly.
But it does not call the plane.
Yeah, exactly.
Okay. All right. So LLM will give instruction to somebody and the person will not call the function.
Yeah, exactly.
All right. Thank you, sir.
You're welcome.
So I'm curious to know who the person is, sir.
It's the developer of the app that designates who that person is and how that person should go about carrying out that function.
So is it the agent now in this case, sir?
No, the developer that is building the
No,
app.
I mean, in sense, is it the agent that the LLM will
The LLM
tell?
is part of the agent now. So
Is the reasoning part of the agent? Yes.
yes, the LLM is part of the agent. So it's not the agent. Well, the tool itself, the tool and whatever it's calling it, they are all part of the agent. So and sometimes the tool itself can even be an agent in a multi-agent
System.
system. An agent itself can be a tool.
Serious.
It depends on how the
Thank you,
system
sir.
is architected. Yeah. Welcome. Adobe says the code writer. Okay, so ladies and gentlemen, if we don't have any further question, I think we may call it a night, and see you
I'm
on
here,
Thursday.
sir. I'm
You
still here,
want?
sir. I raised my hand, sir.
Okay, please go ahead.
Yes, so regarding the last class, so we looked at chaining, I can't remember, like chaining several kind of like piping. So I can't recall what we call it. Like piping two
Building
different
chains.
where we did, yes, building chains. Thank you, sir. So I'm looking at, is it possible to build chain with this? Because the issue I'm seeing here is that since it will not be the kind of like the LLM that is or the agents that will be kind of like calling this function itself. Is it now possible for someone to kind of like now chain a function call output or to pipe it? Yeah.
Okay. I'll answer you this way. I'll ask you to go and look up runnables and runnable pass-through in the LangChain. Runnable
Ru-
and runnable pass-through in LangChain.
Okay, runnable and runnable pass-through.
Yes.
All right. Thank you, sir.
That's awesome. And everyone else, I think you should also do that because that knowledge is valuable to all of us. All right, I guess we can round off now and see you on Thursday. I had intended to complete evaluating your task 1 today, but I wasn't able to do that, so I'll get on that tomorrow. But hopefully before the end of tomorrow, those who have submitted the task and who meet the cutoff would be promoted. And once you're promoted, you can see the next task. The deadline for the next task is on Saturday. Just build on. So we are building, each task is building on the previous one. That was particularly why I requested that you use something from your own experience in the very, very first task, so that as you're working on it, it's meaningful to you. You have all the necessary context, and that makes it the better learning, or better learning value to you. Adobe, please go ahead. Runnable pass-through, PASS through THROUGH.
All right. Got it. Thank you.
Okay, you're welcome. All right. Good night, everyone. See you all on Thursday.
Good night. Thank you and see you.
Good night.